All right, part F. 3 natural log of x minus 1/4 natural log of y plus 1 plus 2 natural log of z squared minus 4. Okay, and then it says to write as a single log expression. So to put all this together, the first thing I'm going to do is put all of the coefficients to be exponents. So that would be natural log of x cubed minus natural log of y plus 1, and all of this has to go to the 1/4 power. So then plus the natural log of z squared minus 4 squared. And then subtraction, like I have here, I can combine by division inside the natural log. So x cubed divided by y plus 1 to the 1/4. And then plus the natural log of z squared minus 4, all of that squared. And then these final two will combine by multiplication. Natural log of x cubed times z squared minus 4 squared all over y plus 1 to the 1/4. Cool. All right, so number 3. Find the derivative of each function. Use the rules to make them easier. Then fill in the information in the table. Okay, so at each one, I'm supposed to see if it's increasing or decreasing. So part A says natural log of x plus 5 times the natural log of 2x minus 1. So whenever there's multiplying this like this would mean the product rule. So I'm going to go look and see if there are any rules that would make it so I didn't have to use the product rule. Aha, the first rule. So the first rule up at the top, if you have the natural log of two things multiplied together, you can separate it to be addition. And I think I'm going to use that. So this is the same thing as the natural log of x plus 5 plus the natural log of 2x minus 1. Now if I take the derivative of this is not so bad. So the derivative of natural log is 1 over x plus 5 times the derivative of the inside portion. Derivative of x is just 1, so I'll leave that alone. And then the derivative of the second part right here would be 1 over 2x minus 1 times the derivative of the inside. Derivative of the inside part is just 2. So I get 1 over x plus 5 plus 2 over 2x minus 1. And I need to figure out a prime when x equals 2. So a prime of 2 would be, so 2 plus 5 is 7, 1/7. And then plus 2 over 2 plus 2 times 2 minus 1, so 2 over 3. So I actually feel like I don't really need to do anything else. I don't need to do any mental math. I know this is positive. So at x equals 2, it's increasing. At 5, a prime of 5, I get 1 over 10 plus 2 over 10 minus 1. 10 minus 1 is 9. So this is still something positive. So it's still increasing. At x equals -8, I would get, let's see, -8 plus 5 is still -3. And then 2 over -16 minus 1 is -17. So whatever this is, that's certainly negative, which means it's decreasing. Cool. B. And there's a hint here. So b is natural log of the square root of x equals x squared plus 1. And hint, use the natural log rules first. So the first thing that comes to mind is whenever I see a square root, I like to rewrite it as a power. So that would be xe to the x squared plus 1. All of this to the 1/2 power. And the beauty in doing that is I actually can take the 1/2 out and rewrite this as 1/2 natural log of x e to the x squared plus 1. And that's definitely better because I was going to have to do the chain rule or something with the square root. And actually, I think we could even go farther than this. Since this is multiplying, we could use that rule we found before, y equals 1/2 times the natural log of x plus the natural log of e to the x squared plus 1. Ooh, which is nice because we now know natural log and e cancel. So this is even simpler, really. 1/2 times the natural log of x plus x squared plus 1. And I think this will be easy to take the derivative of because we can ignore the half. Just keep it as is. The derivative of natural log of x is 1 over x. The derivative of x squared is 2x. And the derivative of a constant is 0, so we'll just drop that. So yeah, using those rules in advance really helps when you take the derivative. Okay. C of x equals the natural log of 4x over 5x cubed minus 2. Okay, so when there's division like this, we can rewrite that as the natural log of 4x minus the natural log of 5x cubed minus 2. So the reason I chose to do that is, as it is in the statement of the problem, that would require me to do the quotient rule because there's division in here. But if I use the log rules, I no longer have to do the quotient rule, which I think is a great thing. So let's see, derivative of this might not be so bad. Y prime would be 1 over the inside function, and then times the derivative of the inside, which is just 4. And then same thing, 1 over the inside function, and then times the derivative of the inside, which would be 15x squared. Clean that up just a teeny. The 1 over x, and then minus 15x squared over 5x cubed minus 2. And then I need to figure out what that is at -1. So when y prime, when x equals -1, I get 1 over -1, so -1, and then minus 15, let's see, -5 minus 2, which is -7. So I get negative minus a negative, so that's -1 plus 15 over 7, which I'm pretty sure that's something positive, but just to be safe, let's use a calculator. -1 plus 15 divided by 7. Yeah, so I do end up with something positive. Means it's increasing. Okay, so the next thing I need is y prime specifically at x equals -4. And I think this time I'm just going to use a calculator for the whole thing instead of mental math. So I get -1/4 and then minus 15 divided by -1 squared. And then all of that gets divided by, all of that gets divided by 5 times -1 cubed minus 2. Alright, so I end up with something positive when I punch that into a calculator, so it's increasing. So y prime at x equals 2 is my next one, something I'll put into a calculator. Okay, this time I got something negative out. It tells me it's decreasing. Okay, and then now I'll try plugging in 6. Alright, and I get something negative. Oops. So y prime evaluated at x equals 6 is also something negative, so I know it's decreasing. Alright, I think number 4 is the last problem in the section. Okay, f of x equals x cubed e to the 0.26x. Find the exact critical points and determine where the graph is increasing. Okay, so this to me is a product rule. So f prime of x is going to be the first times the derivative of the second plus the second times the derivative of the first. Okay, so x cubed, and then the derivative of e to a power is e to the same power, then times the derivative of the power, which is 0.26. Plus e to the 0.26x times derivative of x cubed is just 3x squared. So a little bit of simplification can happen here. In fact, actually, I think I will factor out an e to the 0.26x x squared times x squared. So if I factor that out, I'm left with an x times 0.26. Actually, I should just make that. So if I take out x squared e to the 0.26x, I'm going to be left with 0.26 x. Okay, and then taking it out again, I just get 3 here. So I think I said that weird, but so in this line, I factored out e to the 0.26x x squared, and what's left is 0.26x plus 3. So it says to find the critical points, and the critical points are wherever the derivative is equal to 0 or not defined. So I'll set this equal to 0. And so there's 3 things multiplying together, so I can set each one equal to 0. Okay, so the first thing I'm noticing is that e to a power is never going to equal 0. It's like 2 times 2, well, it's 2.718, blah, 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 multiplied by itself multiple times. So I'm never going to get something 0 or negative, so that has no solutions. Solution to this is just x equals 0. And then to solve this one, I could subtract 3 and then divide by 0.26. And then I'm going to put that into a calculator just to see if that's an ugly decimal or if that's not too bad. -3 divided by 0.26. That's pretty bad. We'll leave it as is. Okay, so these are my critical points, which means I'm going to make a number line and test points. So 0, and when I put that into a calculator, I got approximately -11.5. So all the way out here, -11.5-ish, not exact, but it's close enough. So I want to check out f prime of -12, f prime of -1, and f prime of 1. So all I'm doing is choosing a point here, here, and here. It doesn't have to be the same ones I chose. I just tried to pick ones that would be easy to do mental math with. So the -12 one will probably be the hardest. So that would be e to the 0.26 times 12 times 12 squared, and then times 0.26 times 12 plus 3. Okay. E to the 0.26 times 12. And then all of that times 12 squared. And then times let's see, that is 0.26 times 12. And then plus 3. Okay. Well, I get a very, very large positive number. And let's see, now we'll do -1. Okay, if I plug in -1, I also get something positive. And finally, we'll do just 1. Okay, I also get something positive. So let's see, what's the question? Okay, determine where the graph is increasing. So it's basically everywhere. Well, let's write this somewhere nice. Let's write it down here. So -infinity to the critical point, which is -3 divided by 0.26. And then from that critical point, -3 over 0.26, all the way to 0, and then from 0 to infinity. Cool. Okay, any questions? Pop them on the discussion board.